Okay, kiddos, what we're going to start to learn about today is dimensional analysis. What dimensional analysis is a method of solving problems using the dimensions or units of measurement. And one of the things we're really going to employ is the use of ratios. What a ratio is anything that is equal or in proportion to one another. And you know lots of ratios, and I have several listed here on the right. For instance, 12 inches is equal to a foot. 1 minute's equal to 60 seconds. 2,000 pounds is a ton. But you can also do other proportions. For instance, 2 patties is equal to 1 Big Mac. Not that they're the same, but that's the recipe on how you put that together. We can also extend that to molecules as well. 2 atoms of hydrogen is equal to 1 water molecule. Or even 1 atom of oxygen is equal to 1 water molecule. So those are just several examples of the types that we'll be using. You will have your own sheet that has lots and lots of different ratios on there, and you will not have to memorize very many of them. You should be familiar with the metric system at this point in your life. We have our standard units of measure. For instance, for mass we have the gram. In physics we use the kilogram. In volume we have the liter, or we can have things like cubic meter or cubic centimeter. For distance, the meter. For time, seconds. And for temperature, Celsius or Kelvin. So what we're going to do now is use the staircase method to convert the following measurements. Okay, so using the back of your conversion chart, you can see there is a staircase back there with each of the prefixes for the different metric units of measure. Starting at the tippy top, you have a capital M, which stands for mega, followed by kilo, hecta, deca, your base unit, which is going to be grams, liters, or meters. In fact, you probably could write that down. The base unit is grams, liters, or meters. Then underneath we have a single lowercase d, which is deci, then centi, then milli. Underneath that you have a Greek letter known as mu, which looks like a U with a little extra flare. That stands for micro. And then down at the very bottom you have an N, which stands for nano. If you've now forgotten everything I've said, you can flip to the front of your chart, and it has all the prefixes with their correct symbol beside them that you can use as reference. Now back to the staircase side. What we're going to do is we're going to convert from centimeters to meters using the staircase method. So if you will put your finger on the centimeter, think about what you're looking for. That's right, you're looking for the C. And then we're going to be converting to meters, which is not the M on that chart. The meter is the base unit. So you're going from the C to the base. To go from the C to the base, you have to move to the left. And how many steps do you have to move? Don't count the step that you're on, just how many steps you have to move. And that would be 2. So we're going to move the decimal 2 spaces to the left. So at the back end of this number, right here, we have a decimal. And what we're going to do is we're going to scooch it, if I can figure out how to do it, scooch it over to the right too. So our answer is 0.36. I do like to have people put zeros in front of the decimal place, so you should do that too. Let's look at the next number. We have 14.8 grams, which is our base unit. And we are going to micrograms. So put your finger on grams, which is the base, and then count down how many steps it takes you to get to micro. Again, don't count the step that you are on, just the steps it takes to get you there. I count 6 steps. So we're going to take this decimal and move it over 6 times. And I'm going to write the answer out here. So I get okay, a little funny looking, but that's the answer. What you need to do now is you need to pause this, and you need to try the other 2 on your own, and then turn this back on and check your answers. Okay, so going from kiloliters to liters, it's going to go from kilo to the base unit of liter. That's 3 steps. And so the answer is, and then the next one, you're going from meters to kilometers, and that is 3 to the left. So again, I'll kind of put this answer outside the blank. We've got 1, 2, 3, and then the number. So that is the answers for that slide. So the next thing that we're going to do is we're still going to be using the staircase method, but it's a little unusual because now we're going to be making up our own ratios. The thing about dimensional analysis, it really doesn't matter what the ratio is as long as the ratio is true. And we could choose really infinite numbers of combinations of numbers to make up a correct ratio, let's say between millimeter and meter. However, I like to do it the easy way, which means I'm going to be using numbers like 1, 10, 100, 1,000, 0.1, numbers like that, instead of numbers like 0.3682, which you could certainly use, but it just kind of confuses the issue. So, what we're going to do is we're going to do this first couple together, and I'll let you practice the other two. And so what you want to do is you want to look at your blanks and determine which unit is larger. So between millimeter and meter, which is the larger unit? And the answer is, well, it's a meter. Okay, so what we're going to do is we're going to put the big one by the largest unit, and that would be the meter. The next thing we're going to do is we're going to count how many steps over it takes to get from our meter to millimeter. And again, it doesn't matter which direction, it's just how many steps. And so to go from meter to millimeter, so I'm going from the base to the M on my little staircase chart, it takes 3 steps. And that means I need to put a 1 with 3 zeros. So that is a true ratio. There are 1,000 millimeters in 1 meter. And again, there are many, many other answers, but this is the easiest way to do it. So the next one we got gram and decagram. So looking at your chart or in your brain, which one is larger? So the larger answer is decagram. They won't always be on the right, they just have to be this time. Okay, since the decagram is bigger, we're going to put a 1 there. And then we're going to count how many steps it takes to go from decagram to gram, which remember gram is a base unit. So looking at our chart, it looks like it takes 1 step. So guess how many zeros we're going to put next to that 1? The answer is 1 0. So what you need to do now is you need to pause this thing and then try the other two by yourself and then come back for the answers. Okay, so the last two, the bigger unit between kilometers and, or not kilometers, excuse me, kiloliters and centiliters. Kilo is the big one, so we're going to put the 1 there. And then if we count, the centiliter is 5 steps away, so that would be a 1 with 5 zeros. And then between decimeter and kilometer, kilometer is the big one. And if we count the number of steps, deci is 4 steps away, so 4 zeros. Just like that. So these last 4 problems, what we will be using is a process called dimensional analysis to solve these. And so even though on some of these you could solve them by simply using the staircase method or by doing just some math, fiddling with your calculator and getting the answer, I really do need you to use the process called dimensional analysis because there will be problems that we will use it later or solve later that can only be solved by dimensional analysis. So I am teaching you on things that you should be able to solve anyway and introducing you to the method of dimensional analysis. So the very first thing that we do is we take the number that's given to us. In the case, this is really easy, not any words in this problem. So we're going to take the 0.087 along with its unit of nanometer, and we are going to put that in a ratio over 1. So doing that, we are not changing the value of that whatsoever, we're just setting it up as a fraction. The next thing we're going to do is we're now going to multiply it times a ratio. And the point of this is that we're going to be converting from nanometers to decimeters, so we need to cancel out nanometers. And so if this were algebra, in order to cancel out that nanometers up here, you would need to put a nanometer down there. And so hopefully you guys can see that. And so by putting the nanometer down there, the next thing we do is we ask ourselves, okay, we need some kind of ratio between nanometer and decimeter. And we should be able to look in our brain or look on our chart and come up with some kind of conversion factor, either directly or indirectly, to take us from nanometer to decimeter. So now we can do that because we just did that on the last slide. We can go right from nanometer to decimeter. So now we just need to come up with a ratio. And we are going to be ignoring that first fraction, this one here. We're going to be ignoring that. And just coming up with a ratio, any ratio to put in here that is true between nanometers and decimeters. So I'm going to use the technique we used on the last slide, which is called which one's bigger. And between decimeter and nanometer, the one that's bigger is decimeter by far. And so we find the decimeter on our chart. We can count down to nanometers. You ready? Here we go. 1, 2, 3, 4, 5, 6, 7, 8. It is 8 steps. Count that again. Yeah, it's 8 steps. So what we need to do is on the bottom, we're going to put a 1 with 8 zeros. 2, 3, 4, 5, 6, 7, 8. Or those of you that are fancy pants, you can do 1 times 10 to the 8th here. Alrighty. So now what we need to do is we need to plop that in our calculator and come up with an answer. Alrighty, so when I put that in my calculator says to me, actually I'll show you what it says to me. It says 8.7e negative 10. How you're going to write that is 8.7 times 10 to the negative 10th, because that's tacky looking, so we're going to cross that out. And then we need to put a unit on our answer, and the unit on our answer would be the unit at the end, which is decimeters. Alright, here is example 2. So we're going to start it out the same way. We're going to write down what they give us along with the label over 1. Again, it doesn't change the value, but it gets it set up as a fraction. So again, we're going to multiply, and we're going to take whatever this unit is here, and we are going to put it at the bottom every single time. Alright, do we know any conversion to go from gallons to centiliters? And normally this is in class where I would pause forever, waiting to see if somebody would find gallons to centiliters. And you'll look on your chart, and you will see there is no gallons to centiliters. Now you probably could come up with one, but that would require math, and we're not going to do math before we do math for real. So we need to find a gallon to any kind of liter. It doesn't matter what kind, gallon to milliliter, gallon to liter, whatever. And if we look at our chart, we will see that in the first column, fourth thing down, there's a gallon to liter. That's great. That is heading us towards the metric system. So we're going to go ahead and do gallon to liter. Now looking at that chart again, it's not a conversion that we have to come up with. They gave it to us. It's just a matter of substituting in the numbers. So if I look at my chart, I can see that the 1 is next to gallon. I'm going to put the 1 next to gallon. I can see that the 3.78 is next to liter. I'm going to put the 3.78 next to liter. Now, my gallons have canceled out. And if I solve this problem right now, I would be left with liters. However, I need centiliters. So I've got to keep going. So we just put another ratio. So to put another ratio, we're just going to look at the unit we left with, which was liters, and we're going to put that down at the bottom. Now we need to find a conversion now between liters and centiliters. That's something that we can do. That's something we did a couple charts back, is come up with some kind of ratio between liters and centiliters. This is the one where we use the staircase. And so, which one's larger? That would be the liter. How far away is the centiliter? Well, how many cents are in a dollar? That would be 100. So this would be 100 centiliters in a liter. That cancels out our liters, and we are left with the unit that we want, which is centiliters. So now we need to put this in our calculator by multiplying across. When we multiply across, and we can ignore all the ones on the bottom because dividing by 1 doesn't do anything, we get the answer on our calculator of 21, actually I'll write the whole thing out, 168. Okay, now it's okay for you to go ahead and round it. We're going to learn about rounding in the next couple days anyway, so 21.2 or something like that would be just fine. But we have to have units on our answers. And the unit on that is centiliter. And so that is my final answer. Let me go ahead and take this opportunity to tell you a little bit about how this problem would have been graded if it were a worksheet or a test or something like that. This tippy top part right here, beep, 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 beep. Oops, my pen stopped working. There it is. That would be worth 2 points. The answer is worth ½ a point. The unit is worth ½ a point. So you can see that actually just coming up with the answer, like if I started this whole problem over again, I did in my calculator, I said the answer is 21.2, I would get ½ a point out of 3 points. You must show your work every time in dimensional analysis. So the last problem that we're going to be doing before the fun word problem that you haven't seen next is example 3. You'll notice it has exponential notation or scientific notation. I will have to show you how to put that in your calculator tomorrow when you come to class. And so if you remind me, we will do that together. And if you know how to, that is awesome. So we've got 7.85. Hold on. So I have 7.85 times 10 to the 10th centimeters over 1. Diagonally, I know I'm going to put centimeters. Do I know any conversion factor that takes me from centimeters to miles? If I look at my chart, I think I only have 1 mile on there, and that's miles to feet. So I can go from miles to feet, no problem. But there is no centimeters to miles, so I have to find a new path. Is there a centimeters maybe to feet? And then I can go from feet to miles. Let's look at our chart. I see a centimeters to inches. We could use that. We could go from inches to feet. Oh, there it is. I see it. There's a centimeters to feet. Third thing down, first column. So I'm going to go from centimeters to feet and then to miles. So centimeters to feet. That's a conversion factor given to us. It's on the chart. It says put the 1 by the foot. 1 by the foot. And 30.5 by centimeters. So now we're in feet. Got to keep going. Feet on the bottom. So from feet we can go to miles. And if I look at my chart, the feet to miles is in the second column, fourth thing down. And it says 1 mile equals 5,280 feet. Feet cancel out. And I'm left with mile, which is the answer that I want. So, putting in this in our calculator. And it shouldn't take you very many keystrokes to put in that 1.85 times 10 to the 10th. And again, I'm going to show you how to do that tomorrow. So, what I'm going to do is do 7.85 times 10 to the 10th divided by 30.5 because it's on the bottom, divided by 5280 because it's on the bottom, and then hit equals. And when I do that, I end up with a gigantic number. I'm going to round it to the nearest whole number. 5, 7. And the units on that would be miles. Okay. So again, what I was doing was that since this number was on the bottom, I divided by it. And since this number was on the bottom, I divided by it. And that's kind of the rule to follow, is any number on top, multiply, any number on bottom, divided by. Alright, for this last problem I've cleared out the PowerPoint slide to give myself plenty of room to work out the problem, but hopefully you have that PowerPoint slide in front of you. And it talks about you preparing chili for a fundraiser. And we go through that, and there are so many words, and there are lots of numbers. It does make it hard to figure out how in the world am I going to start this problem. And so what I always ask myself is, what is the question asking? Like if I read the whole thing, what does it really, really boil down to? And when I do that, the question actually is, how many bottles of chili powder do I need? That's really what the question is. Okay, and then the other thing is I have to figure out my known quantity, what I'm going to start out with, what's going to determine ultimately how many bottles that I need. Okay, so if we look at the prompt, it says that we need to prepare 600 servings of chili, which is true, we do. And it tells me that the recipe serves 10 people. Well, am I serving 10 people? Well, no, I'm actually serving way more than that. It says you need 2 teaspoons of chili per recipe. Am I making one recipe? Well, no, I'm going to end up making more than that. The last thing the prompt says is that a bottle contains 48 teaspoons of chili. Do I need 48 teaspoons? Well, I have no clue. That's how many is in a bottle, but I don't even know how many bottles I need. So really, what it comes down to is it comes down to the 600 people that I'm having to serve at my, cannot spell people today. Oh well, it happens. So, the 600 people that I'm having to feed. So, I'm going to start out with 600 people over 1, which means diagonally I've got people. Do I know any relationship between people and the number of bottles that I need? And the answer is a big old no. But I know relationship between people and my recipe card. And my recipe, it says that 10 people eat 1 recipe. Alright, so now I'm in recipe. Do I know any relationship between recipe and bottles? I could figure one out. I'm sure a lot of you smart guys out there are already probably doing that. But no, in my prompt, I don't have any relationship between recipe and bottles. What I know is between my recipe and how many teaspoons it's going to take. And it says that 1 recipe takes 2 teaspoons. Got to keep going. Yes, it's a long problem. We can do this. So we're going to go from teaspoon to bottles. Score. It tells me teaspoon to bottles. And if I read, it says 48 teaspoons in 1 bottle. So now all of these cancel out. And you don't actually have to mark these out. I just do so you can see them, so that we're left with bottles. And now we're ready to do math. Now, again, numbers on top, multiply, numbers on bottom, divide by. So in my calculator, I'm going to do 600. The next number I have, because I'm ignoring the ones, multiplying by 1, dividing by 1 doesn't do anything. So the next number I have is this 10 here. It's on the bottom. So that means I'm going to divide. The next number I have is this 2, which means I'm going to multiply. It's on top. The next number I have is 48. Again, it's on the bottom. I'm going to divide by. And that will give me the correct answer. So let me put that in my calculator real quick. And when I do that, I get the answer of 2.5, which if any of you have been to Walmart, know that you can't buy 2.5 bottles of anything, so you're going to buy 3. 3 bottles of chili powder. And that's how you do that. To finish this off, I have a few closing thoughts. Make sure you show your work. No work, no credit, no kidding. You must show your dimensional analysis work. But Miss Francis, I've got the right answer. Nobody cares. We need to see your work on the AP test. For those of you taking AP chemistry in the future, they will not give you any credit unless there is work showing up with it, even if the answer is correct. So make sure you show your work. That's where most of your points are going to be at. And tomorrow what we will do is we will work on dimensional analysis worksheet number 1, and we will work on it together, and you can turn it in during class. Good night, y'all.